Today we want to look again at graphs of sine and cosine, but more generally, the effect of operations on the graph of a function. So there are two different operations that we want to perform, and there are two locations that we want to perform these operations. So we start with sine and cosine because it's really easy to track what changes if we, by changing the amplitude and the period, and changing any vertical shifts or horizontal shifts. So let's talk about the operations that we want to perform, and let's talk about when we want to perform the operations. What operations will we be performing? So let's start off with that. What operations and what do they do? So the ones that we've I know I line up all my outlines just straight up and down. I'm sorry if it bothers you. Then I don't know. Drop it into Photoshop later. So what operations and what do they do? The operations that we want to look at are multiplication. That's the one we looked at last time. And we also want to look at addition. So when we multiply, the effect on the graph is to have a stretch, either a stretch where things get longer or a squish where things get more compressed. So this would make a stretch or a compression. That's the effect of multiplication on the graph. We'll get a stretch or an inverse stretch, a compression. We didn't talk about this specifically last time, but when we do addition, addition is just going to move things. Addition is just going to produce a shift. So multiplication will produce a stretch or a compression, and addition will produce a shift. So the multiplication is changing the shape, but the addition is just moving things around. So stretch or compression, this is going to change the shape. By stretching it or shifting it. So like if you have a picture and you just grab like the lower left corner and pull off to the side, that's going to change what the picture looks like because it's going to stretch, or you can push it in and you can compress what the picture looks like. When we're doing addition, we're just going to perform a shift. The picture is going to stay the same. The shape is going to stay the same. It's just going to move around. So the same shape moving around. So it's the same shape, but it'll move it around. This is like clicking on the picture itself and just moving it around with the mouse. Doesn't change what the picture looks like. It just changes where the picture is on the page. These are the first two operations that we want to look at: multiplication and addition. We want to talk about when we will be performing these operations. So when I say when do we perform the operation, I'm talking about in terms relative to when the function gets applied, when we take the sine or the cosine. So there are two things that could happen here. Either we can do the operation before the function, or we can do the operation after the function. So A, we can do the operation before the function, or we can do the operation after the function. When we do the operation before the function, we end up with a horizontal change. So we'll have a horizontal stretch or a horizontal shift. It's some kind of horizontal change. So when we do things before, we get a horizontal change. If the multiplication or addition takes place after the function, then we'll have some vertical change. So this actually applies more generally, not just to multiplication and addition. If there's something that you see happening before the sine or the cosine, you should expect some horizontal effect. If you do something after the sine or the cosine, you should expect some vertical effect. So let's sum these up with graphs of sine and cosine. We can adjust the amplitude and the period by performing multiplication after the trig function or before the trig function. So now for trig functions, for graphs of sine and cosine, we use multiplication to change the amplitude and the period. So the amplitude is a vertical change, a vertical stretch or compression. And so that's going to be multiplication after the trig function. Amplitude is a vertical thing, so the operation is after. It's a stretch, so it's multiplication. So amplitude is multiplication after the trig function. So amplitude is multiplication after the function. Multiplication is what makes us produces a stretch or a compression. After the trig function makes it vertical. The period is also multiplication, but this one is before. So this is still multiplication. But the multiplication takes before the trig function. So we multiply the inputs, then we apply the trig function. That's going to produce in the graph a horizontal change because we're doing it before the trig function, and it will be, since it's multiplication, it will change the period. So if we think about what the graph looks like, I'm just going to draw one cycle of sine. We know that there's a top, a middle, and a bottom to graphs of sine and cosine. So here we have the top up here. We have a middle. And we have a bottom. if we want to change how tall the graph is, that is, if we want to change the amplitude, that's going to be multiplication after the trig function. So if the amplitude is some value, let's say a, then I'm going to multiply the sine after. It's multiplication after the trig function. Notice I left this conspicuous big space here. That's because that's multiplication before the trig function. And so that's going to produce a horizontal change. So we also know that there's a period. And then I'm going to realize too late that I wrote this one level higher than I wanted to. So I'm going to maybe shift this up. This is because my whole day started an hour earlier than it was supposed to. Without an alarm clock, I will pretty much get up on time and go through my normal morning and be ready to go at 8:15 when my first class starts. But now everything is just suddenly shifted by an hour. And I'm still not sure why we really still feel the need to do this to ourselves. I mean, I know what the standard arguments are. I'm just not sure that there's not a better way. Anyway, that's one way of identifying when this took place. We know that if we go from one point on the graph to the other end, the same point on the graph, we get one period. That's the length from the start to the start again. How much do we wrap around again? So adjusting the period is going to be a job for, since the period is going to stretch or compress the graph horizontally without adjusting the amplitude. If we use multiplication before the trig function, that's going to stretch or squish things horizontally. So when I write b times theta, I'm using multiplication before the sine. That's going to be horizontal stretch or compression. Multiplication, stretch or compression before horizontal. A is multiplication after, after the sine. So multiplication is going to produce a stretch. After, it's going to be a vertical stretch or compression. Any questions? Every year we kind of have the same conversation. We're like, oh, hey, maybe we shouldn't do this to ourselves anymore. Because it's kind of, I don't know anybody that's really in favor of changing what time it is. I mean, in the fall, when everybody, quote, gets an extra hour of sleep, we change the clock back. So everybody seems to be like, oh yeah, get to sleep in for another hour. See, I don't, because I have animals. And the dog doesn't wake up because of an alarm that goes off on his bedside table. He has a bedside table, but he doesn't wake up because the alarm goes off. He wakes up because it's like, oh, hey, it's food o'clock. So make with the food. And he doesn't care what time it is. So, you know what I mean? So anyway, multiplication produces these stretches or compressions. Multiplication before is going to adjust things horizontally. Multiplication after will adjust things vertically. The other reason that I like to point things out this way is that one of the things that's important to me is that we learn to read expressions correctly. Like we learn to read this expression a sine of b times theta. And we think about the things that happen to the theta. The first thing that theta encounters is b. We multiply theta by b. Then we apply the sine. And then we multiply by a. That's the order of operations in this expression. So if we think about the order of operations, now at this point we should notice that PEMDAS is truly trash now, because where do trig functions fit into all this? Then we regret learning PEMDAS in the first place because we didn't learn how to read things, we just learned how to follow some instructions. But now we got to learn how to read. So let's read the expression. The things that happen to theta: first, we multiplied by b, and then second, we did the sine, and third, we multiplied by a. So here's what I mean when I say we multiply by b before the sine, and we multiply by a after the sine. It's important to be able to read, because there's no t for trig functions in PEMDAS. Any questions? All right. So really what we're trying, I shouldn't just sit here and trash PEMDAS without offering an alternative. So my alternative to PEMDAS is do the repeated stuff first. And then remember that multiplication is repeated addition. So multiplication goes before addition, unless there are parentheses that tell you to do otherwise, some grouping symbols to tell you otherwise. So I also want to update the word parentheses to grouping symbols. Do multiplication before addition, unless grouping symbols tell you to do otherwise. Do exponents before multiplication, unless grouping symbols tell you to do otherwise. Then remember that multiplication distributes over addition, and exponents distribute over multiplication. So do the repeated stuff first, and remember that you can use the distributive property one level below. So my order of operations doesn't simplify into some PEMDAS, but it admits that there are other operations that we might want to perform other than our core operations of addition and multiplication and exponents and things like that. Which is weird, because usually when in the same class we learn PEMDAS, we learn about logarithms, which is going to sit like this. It doesn't sit inside the PEMDAS. What do we do with these logarithms? And it's mostly because we didn't learn to read. All right. So what we want to look at today, the examples that we want to grab today, we're going to switch over to the old Desmos. The examples we want to look at today are what the effect of addition before and after. So addition is going to perform a shift. We're going to have to see the same shape, but it's going to move around. So what I want to look at now is on Desmos. I want to look at the graph of y equals. It's going to look like the sine of. I'm just going to go with sine of x. I'm going to keep our period at 2 pi, and I'm going to keep the amplitude at 1. But I'm going to add something before the trig function. I was trying to decide. I think I use a c when I do it before, and then plus d. I want to look at the effect of addition before the trig function and after the trig function. So read the order of operations here. First, we're doing adding c, and then we're doing the sine, and third, we're adding d. So I've got addition before the trig function and addition after the trig function. So Let's jump over to the Desmos. Let me see, I remember how to do this. All right, so at this point, you should be looking at Desmos. Is everybody looking at the Desmos? All right, so let's take a look at y equals sine of x plus c. I want addition before, and I also want addition after. And I want to add sliders for c and d. So I'm going to grab change the value of c. You can see that c equals 1. If I drop c down to 0, and if I drop d down to 0, you can see what's happening when I change these values. So if I change the addition before the sign, the plus c, that moves the graph back and forth. So I'm shifting the graph. It's keeping the same amplitude and the same period, but it's shifting left and right. And when I grab the d slider, I move the graph up and down. So the addition after the trig function, after we do the sine, shifts the graph up and down. After is vertical, addition is a shift. Any questions? D Slider was my moniker for my heavy metal math band, but then it was too close to some other band that was going on at the time. So, but anyway, moving the D Slider moves the graph up and down, but maintains the shape. The amplitude and the period are not changing. We're producing a vertical shift. Shift because we're doing addition, vertical because it's taking place after the sine. When we change the C slider, we're sliding backwards, we're sliding left and right. It's horizontal because it's taking place before the sine, and it's a shift because it's addition. Any questions? We can add all kinds of things. If I multiply by A and then add an A slider, changing by multiplication will change a vertical shift. Notice that the graph, all those x-intercepts are not moving at all. But if I change A to, let's say, negative 2.2 or 2.2, notice that it flipped everything over. But now if I change the C, I've fixed the amplitude. And if I change D, the amplitude stays where it is. And then if I multiply the x plus c times b and add a slider for that, now I'll be adjusting the period. So notice that it'll stretch out or compress. Stretch, compress. But no matter what I set on my A and my B to, adjusting the C slider moves things left and right, but maintains the amplitude and the period. Adjusting the D slider moves things up and down, but keeps the amplitude and the period the same. The generalized version of this is that if we have a function like, let me turn this one, did I turn that one off? Let's change our function to something else. Like if I have a function y equals 1 over x. If I change y equals 1 over x, if I put the plus c, I have addition before we do. If I have addition before we do the 1 over parts, then changing c moves the same shape back and forth. Because it's addition, it's a shift, since it happens before the function, it makes a horizontal change. If I put a plus d at the end, outside of the 1 over x, then that's going to produce a vertical shift. Vertical because it's after the 1 over x. Shift because it's addition. If I multiply this fraction by a, then adjusting a is going to shift things up, is going to stretch things. So notice that the horizontal, I have this horizontal asymptote and I have this vertical asymptote. I'm going to shift my vertical to 0 so it's easier to see. And I'll shift d down to 0. There we go. So we can see that if I change a, I still have the x and y axes as horizontal and vertical asymptotes. And if I multiply inside by b, it's going to look like what I've done here is just really multiplied by a times b. So it's going to look like it's doing the same thing as a. Any questions? All right. So those are the 4 places that we can put some operation and the effects that that operation and its location will have on the graph of the function. Any questions? Comments? So let's jump to our end goal with this stuff in mind. Our end goal is to look at y equals, and there are 4 numbers that we want to throw in here. I want to be able to multiply on the outside. I've been using capitals and all of a sudden lowercase. Oh well. I use lowercase on decimals. I think that's why. And then I want to use multiplication on the inside to change the period. And then I wanted to use addition. I'm going to weirdly list this one as x minus c. And then I want to have addition on the outside. And we want to recognize the effect that these numbers a, b, c, and d will have on the graph. A is multiplication after the sign takes place. And so that's going to be a vertical because after and a shift because multiplication. B is multiplying by x before the sign takes place. Multiplication will be a shift or a compression. Before will mean horizontal. This subtracting of c, that's going to be change before the sign, and it's going to be by addition. Addition means it's going to be a shift. Before means it's going to be horizontal. And then this plus d happens after the sign. So it's going to be a vertical, and addition means it's going to be a shift. Well, we want to read the order of operations. The first thing that happens to x is we're subtracting c. The second thing that happens to the x is that we multiply the result by b. Then third, we find the sign of the result. And then fourth, we multiply by a, because multiplication goes before addition unless there are grouping symbols telling us otherwise. And 5, we add d. Notice that we did the subtracting of c before multiplying by b because these grouping symbols told us to do that order. Not because they're parentheses, they're grouping symbols. Parentheses is not an operation. It's just telling you when to break the operations or break the order. Any questions? The reason that way that I think about the order of operations is not going to catch on is that I can't summarize it with 6 letters. And the other reason that it's not going to catch on is I can't summarize it with 6 letters and then make people get into fights on Facebook over it. Because I don't like to start fights based on miscommunications. It's like old episodes of Three's Company, but mean-spirited, like more mean-spirited. Show is from the 70s, so there's like this mean-spiritedness throughout the whole thing. But it's a mean-spiritedness that people thought was funny back then. But if you look past that, it's all just about miscommunications. It's kind of like Game of Thrones. Like, imagine how boring Game of Thrones would be if people just had friggin' cell phones. You know what I mean? I know by the time they got away from the books and the showrunners were kind of writing their own stuff, they pretty much had cell phones. Because the guys that the showrunners were like, oh, so ravens are pretty much cell phones, right? And if you got to fly on dragons, then you can pretty much teleport anywhere, right? It doesn't take you time to get anywhere. You know what I mean? Anyway, that's all beside the point. Read the order of operations. We have things before the trig function. This is going to be horizontal changes. And then after the trig function is going to produce vertical changes. We just happen to have names for certain things. For sines and cosines, the amplitude is just this number out in front. Amplitude is A. This number changes the period, and here the period is 2 pi divided by B. The way we want to think about it is that the multiplier is making the x happen B times as fast. So if the B is a 2, then the period goes from 2 pi, drops down to pi because the x's are going twice as fast as they were before. The others have boring names. This is just going to be a horizontal shift. And this plus D is going to produce a vertical shift. We can also think of the vertical shift as the new middle. The horizontal shift can tell us information about the, what I always put this in quotes, the start of the graph. That's where we locate the graph at a top, a middle, or a bottom. All right, so this is what we're going to go into more detail on Wednesday. So today we looked in general about horizontal changes and vertical changes, things before and things after. We talked about stretches and shifts, stretches from multiplication, shifts from addition, and then just putting the one from column A and one from column B, horizontal and vertical, stretch or shift. And then on Wednesday, we'll do some more specific examples related to trig functions, where we look at amplitude, period, horizontal shift, and vertical shift. And I'll clarify what I mean by things like start. That'll do it for today. I will see y'all on Wednesday. Everybody have a good couple of days, and thanks for playing.